Test? Yeah. Hello, everybody, and welcome. My name is Philippe Ozil. I'm a senior developer evangelist at Salesforce, and I'm happy to see a full room. I'm here today to talk to you about platform events and how you can implement an event-driven architecture with platform events. Before I do so, I'm going to have to give you the forward-looking statements. If you've been to a Salesforce event before, you've probably seen this slide a couple of times. What this means is that we're a publicly traded company, so I'm going to talk about product features, and you should not make any purchasing decisions based on what I'm going to say. Only base your purchasing on what is commercially available in the product. That being said, I'm talking about released features, so we should be safe for phone. So my talk is going to be split in two. First, I'm going to talk about event-driven architecture in general, not necessarily in the world of Salesforce, and then I will talk about Salesforce, I will talk about platform events. So let's start with event-driven architecture. So event-driven architecture is a new paradigm. That's not exactly new, but it's a very different paradigm from what was previously in place. It's about real-time event notifications. It's a distributed system that relies on a publisher-subscriber model, and I'm going to go deep dive on what this means. It's also a system that is based on notifications that are actually fired in one way. So there's a fire and forget mechanism. You push notifications to receivers or subscribers. You generally don't have a two-way communication. So that's something that is very different from traditional communications. It has two benefits. It allows to decouple the senders from the receivers because a sender does not know what are the receivers that are receiving a message. There can be a lot of them, so that's also very good for scaling. It's about broadcasting messages. So I mentioned the publisher-subscriber model. Let's see what this means. Around the publisher-subscriber model, at the center of this, there is something called the event bus. In my talk, I'm probably going to use different words. I'm going to use event bus or message bus. Generally, these two words can be used for the same thing, event or messages. So the center of the architecture is about the event bus. Then we got some event consumers or message consumers that are actually subscribing to the event bus. They will say, I'm interested in this particular type of message. And on the other side, we'll have event producers. So the event producer is able to produce a message, and it publishes the message to the event bus. The event producer does not know about subscribers. It only knows about the event bus. So that's what is providing us the decoupling. The producers and consumers are never connected together. There's the event bus in the middle, which serves an intermediate layer. So once the event producer publishes a message to the event bus is responsible for broadcasting the message or the event to the different subscribers. It does not know if there are consumers, but it just broadcasts the message to the event consumer. What is important to emphasize is that the producer will never have feedback about the fact that there were some consumers or that the message was correctly delivered. It's really a fire and forget way of sending messages. This is how we can establish this in a really scalable architecture. So how does this work when you compare it to a traditional request-driven or service-oriented architecture? Here, I've taken an example about an e-commerce solution. It's let's say, an application with different modules: shop, payment, newsletter, inventory, customer database, and reporting. And all of these layers or services are interconnected. Now, the problem with this traditional architecture is that if you want to update one of these services, let's say we want to update the customer database to a new version, we're making some change, adding maybe some fields to the customer database, that impacts all the related services. So there's a ripple effect. That means that you'll have probably to update all the connected services. That's a really big problem with request-driven or service-oriented architecture. And that generally breaks the different services. Now, if we compare that to an event-driven architecture, because of the service, the event bus in the middle, we don't have this problem. We have installed something, we have created an architecture that brings decoupling. These services are no longer interdependent. They rely on this event bus in the middle. So if you want to update one of these bricks, you will no longer have to worry about changing the whole structure unless you're making some changes to the messages. But it's non-breaking. Now let's see how this works. If we just focus on the event-driven architecture, all of these services are connected to our event bus. If I take an example, like if I request an order, I'll publish a message to the event bus. And then the connected services will receive the order event. Now, what is important in the event-driven architecture model is to think about events as state changes, not as actions. So when I'm actually issuing the order event, I'm actually saying the order was sent. I'm not saying I am requesting an order. It's not an action. It's the consequence of an action. So this is a bit of a gymnastic you have to think about. You have to think about past tense, basically. Something was done, something happened. It's an event that notifies. It's not actually something that will directly change data. We don't know about what are the consequences of order event. We just know that from a standpoint of the shop module, we know that the order happened. And then the other services, of course, will be able to interact with the database or the other services that need to be operated. So this is how an event-driven architecture works. Now, let's go into the Salesforce side. Let's look at platform events. Platform events are basically a way to implement this event-driven architecture. Platform events were new, I would say, in summer 17, so last year. And we've updated them in winter 18 with a few additional capabilities. Do some people in the room, have some people in the room used the streaming APIs here? All right, well, quite a few, yeah. So if you've used the streaming APIs, you'll see a lot of similarities. I will go in details about these similarities. Streaming API is also based on a publisher-subscriber model, just like platform events. So there are a lot of similarities between those two. The advantage, however, of platform events is that we provide both declarative approach and a code approach. We can publish and subscribe to messages either with code or with clicks. There's also a big difference with streaming APIs that the messages are strongly typed. So we have different fields in platform events, and these fields are typed. But we will see the details about this in this next slide. One thing that is important also to remember always is that just like for the streaming APIs, we do not persist the messages when we send them and we receive them. The messages cannot be queried. There is no SOQL method to list the messages that were received on the platform event. There is no tab in Lightning or Classic that lists the platform events that were received. We can see the structure of the object, but we cannot see the instances of the object. And then I'll mention one thing. We're able to look at some of the events that were received on a 24-hour replay capability. So we can look what were the events that were received in the last 24 hours. And I'll give more details on that. So let's see how these can be used. One of the first reasons to use platform events is for microservices. You cannot really do platform microservices in Salesforce, but you can delegate actually microservices to an external system. Like, for example, you could use a Heroku application and actually delegate some processing to the Heroku application. And this brings the second point. Platform events are extremely good at integration jobs. For example, when you have multiple platforms with different technology stacks, this is perfect. When you're doing real-time IoT devices control orchestrations, that's perfect. When you have also a mobile application and you wish to receive real-time notifications, that's exactly the good use case for platform events. If you've been around in the zone, you may have noticed the Robotics Ridge zone or the Lego City. These are booths that are extremely using platform events at a really big scale. So that's IoT, mobile, real-time, and also multi-platform, because these devices that are on different booths are actually connected with different platform events and different architecture stacks. And lastly, yes, I mentioned that because last point, the distributing processing power. That's something I just heard about in the last month. Some people actually taking out some processing tasks out of Salesforce and putting them on a Heroku application or on another system. That's a good way if you have problems with limits, if you've been struggling with some intensive tasks that are hitting your limits, a lot of SOQL statements, something like that. You can delegate some processing to an external system, and a good way to do that is to use platform events. So you fire off a job, and then you fire off a platform event once the job is finished so that you can resume processing in Salesforce. This can be good for file processing, for images, video processing, something like that. You don't want to do that on the Salesforce platform. You want to delegate that to an external system. That being said, I'm going to go now in the details about how platform events are different from the streaming API. So for those of you who haven't used the streaming APIs, I need to clarify a bit. There are actually two streaming APIs that you can use. They are push topics and generic topics. These behave a bit differently, but I will cover the differences. First, I'm going to look at this from the data structure point of view. Platform events are strongly typed. They have custom fields which have their own type. We will see that there are a few limitations on the type of field we can have. These are very basic tabs that can be serialized. So we cannot have, like, for example, roll-up fields. We cannot have master detail relationship. Very simple types. Then on the push topic, however, it's a bit different. On the push topic side, the fields that compose the push topic message are actually defined by the SOQL query that defines the push topic. So the push topic is actually generated from a SOQL query. Whenever the result of the SOQL query changes, it issues a push topic notification. So the fields that are in the message are actually the ones that are in the push topic SOQL query. And then for the generic messages, this is fully untyped, so it's a big string of, if I recall, it's about 2,000 characters long, and you can put whatever you want, generally JSON, but you can put also XML or whatever text you want. Then from the publication point of view, in platform events, you can use code or clicks to publish a platform event. And on the other streaming APIs, you don't have the choice about the method to publish push topics, because these are automatically generated for you when the SOQL query changes. And for generic, you only have the REST APIs to publish a generic topic. Then for the propagation mechanism, so all of these are based on pub/sub, so they generally all support broadcast, but the generic topic has actually an interesting way to select only specific receivers. That's rarely used, but that's a small difference that the generic topic has. Lastly, for the subscription side, we can use any method for platform event, codes, or clicks. And then for streaming APIs, we can only do so with code. And we use something called the Bayeux client. I will go into detail about Bayeux. This is what is actually supporting our streaming APIs and also the platform events. But this requires code. So let's see now, what are the options to publish and to subscribe platform events on Salesforce platform? So on the Salesforce platform, we have the platform event bus. Just like we saw in the previous slides about the publisher-subscriber model, it's exactly the same architecture. This time, we're inside Salesforce. We're going to have some publishers. We can publish events on the Salesforce side, but we can also publish events outside of Salesforce. If we are using an external application, or if we're using the Salesforce platform, we can use the APIs, SOAP, REST, or BOC. These APIs can be used to create a platform event, and I will give you some code examples just after. If we're using now only the Salesforce platform, we have access to Apex also additionally. We can create a platform event using Apex. And we can also use the declarative tools, like the process builder or the visual workflow. Now, let's look on the receiver and on subscribers. We can also subscribe to platform events from external apps, or we can also use the platform also to subscribe to platform events. If we're using external apps, we have to use code to receive platform events. We have to use a Bayeux protocol client. There are several implementations of this protocol that are available. These are the ones that are the most common: Comet, Socket.io, and Fay. Comet is actually the reference implementation, so that's the one you'll hear about the most often. It's generally very good. You can use the other ones, but generally Comet does the job. Comet allows you to receive these platform events, and I will go into the detail about the Bayeux protocol later. Then if you're receiving platform events inside Salesforce, you can use a basic Apex trigger. It's very similar to a classic trigger. I will show you code samples. And lastly, you can also use the declarative tools to trigger a process or a workflow when receiving a platform event. So these are a summary of all the options you have to publish and to subscribe platform events within or outside of the Salesforce platform. Let's now see how the Bayeux protocol works. So the platform events are actually relying on a push system. Just like event-driven architectures, we are pushing messages from the server to a client. The client can be a browser, generally, or it can also be another server. That's perfectly acceptable. Now, this Bayeux protocol is actually based in using JSON. That's the structure of the data that it contains. And there are several transport modes. The transport is the way we send the messages. We can use the polling transport or the streaming transport. And for those, there are different implementations. If we use polling, we use HTTP requests. So that's something that we just basically request new messages from time to time regularly. This is not so good because it doesn't scale. Now, we also have the second option, streaming transport, which is based on WebSockets. WebSockets are a bit newer than HTTP, of course. They've just been out for a bit less than 10 years. And they're very good at this because they're a way to receive streaming communications. So with WebSocket, basically, the server is able to directly communicate to the client. With HTTP, the client has to issue a request and gets a response back. So it's a two-way communication, but it's not very efficient because when there are a lot of clients with HTTP, the server gets basically bombarded by requests. Do I have a new message? Do I have a new message? Do I have a new message? So it's not very efficient. Now, the good news is that the Bayeux protocol is very flexible. It will automatically take the best transport option for you. So if WebSockets are available on your client, it will take WebSockets. And that's very good because it will allow it to scale. You don't have to worry about all of that, but I wanted to give you a bit of a technical overview about how things work behind platform events. Generally, you will use WebSockets, so that's going to be fine. Now, I mentioned that we have some limitations on the type of records and the fields that we can have in platform events. So here I'm going to go through the details. First of all, when you create a platform event, it's a bit like if you create a custom object, except that there is an __e suffix that denotes that it's an event, so it's not being saved again. And there are also some security aspects to it. We can have read-write permissions on those platform events. So if you want to secure them, you can. But you cannot filter specific types of events. So it's either a client has the right to read or to write messages of a given type, but they cannot. You cannot filter like if this message contains this data, then I can filter it or not. So the read-write permission is only on the record. It's not on the fields. We don't have field-level security for platform events. Then for the fields, all fields end with just __c, just like custom objects and custom fields. And they are limited to a few basic types. And basically, this limitation comes from the fact that we need to be able to write these fields in JSON for the Bayeux protocol transport. So text, number, checkbox, date, time. We don't have any things like master details relationships or person or whatever. These are really basic types that are actually supported in JSON. Now let's have a look at the replay capability. I mentioned that platform events are not something that we persist, but we are able to replay events that are issued in the last 24 hours. So how does this work? For each event of a given type, there is something called a replay ID, which is incremented each time we publish a new event. So here you can see number 1, 2, 3, 4. And you have the capability to replay a message stream from a given replay ID. So for example, here we can replay all events starting from event 2, and we will receive them in the right order. Now, we cannot replay event 1 because it was issued before the replay window. And then if you don't know about the last message that we received, there's always this little trick to use the reply ID of -2. It's not very obvious, the choice of -2, but it allows us to replay all events that were received in the last 24 hours for a given platform event type. So that's how you can replay messages. If you're using a mobile app that gets offline for some reason, you can replay the messages you missed in the last 24 hours. This retention window is not something you can change, so you'll have to, of course, to deal with the events that you may have missed that were issued before 24 hours. Now, let's have a look at a general pattern that is the best practice when you interact with a server and a client with a platform event. So the first thing to remember is that we have limited field types that you can use in platform events. So generally, when you issue a platform event, you don't want to copy a whole object. What you want to do is send a platform event with just a reference to the object that is, or the objects that are impacted by this platform event, and then you process the event. Just keep the ID reference and process the event. And in the meantime, you can query the object on your client to get all the information fields you need, so that whenever this message was issued at a time t, and you receive it maybe 24 hours, the object may have changed, so that's why you want to do the querying after having received the message. So if it's a replay event, you want to make sure that you query the object and you don't have a static copy of the object properties inside the message. That's a good way to making sure that you're up to date with the messages you receive. And it's also a good way to keep your platform event light, so that if the object structure changes, you don't have to change the definition of your platform event. You can still keep the same platform event. The IDs will be the same, or new ones, but you don't have to worry about the structure of the object to copy them in the platform events. Now let's go into code samples. Let's see a bit how we can publish and subscribe to platform events. Here, you have the basic code to publish a platform event. If you create a custom object, this is very, very similar. The thing that is really different here is this method, this static method from the EventBus class. It's a way to publish a platform event. So this publishes just a single platform event. You notice that the event is written with __e. And this method works with a single platform event, or you can also support a list of platform events. So you can publish a list of platform events. Now, limits do apply to this. So you have DML limits, because we're issuing messages. So you want to use generally batches of messages when you fire more than one. And you can just use the same publish method with a list of platform events. When you publish a platform event, we're actually getting a database save result. We're actually not saving in the database, but we're using the same class that we use when we create a custom object. And then you can check with this database result thing if there is an error when you publish the message. The result.is success does not mean that there were some subscribers to the message again. I really want to make sure you understand that. It only means that the message was published to the bus. Maybe no one is listening for it. That's not the problem of the bus. The bus is just making sure that you get the message out. Now, let's have a look at the other side, when we want to subscribe to platform events. Well, this is a basic Apex trigger. The only constraint is that we can only use after insert. That's the only limitation with platform events, because we can only react to a platform event. We cannot do a before. We cannot change the content of the platform event. And then there's really nothing particular to this code. It's a basic trigger. Again, the __e for the record of the platform event, and custom fields with __c. So very simple. You've seen that code probably several times in Apex. Now, for the REST APIs, it is exactly the same thing as for creating an object. So it's a post to give an URL. And notice that the event is stored actually under S objects. So it's exactly in the same place where you would have custom objects here. There's nothing specific about publishing a platform event using the REST APIs. Now, let's see something a bit more complex now. How can you subscribe to a platform event when you're on a client that is like inside a browser, and you have to do JavaScript to do that? And to do that, you're using, in this example, a Comet library. Comet library is one of the options to receive platform events using the Bayeux protocol. So first of all, you have a big chunk of configuration. We are actually connecting to the Salesforce instance. So in this example, we assume that the JavaScript code here is running inside the Lightning page. So we are running on the host that is running our Salesforce instance. We are registering to an endpoint that is called Comet. And we are getting two things. We configure our Comet client with the session ID. So we have to first make a call to get the current session ID, use the Salesforce session ID, and to pass it in an authorization header on our requests. So remember that platform events are actually secured by OAuth authentication. You have to use a Salesforce user to authenticate against the Salesforce platform before being able to receive platform events. So this is how we do it. We retrieve the session ID from Salesforce. We pass it in the authentication header for a request. And then here, if we're using the Lightning platform, we have to disable WebSockets. So we have to basically fall back to HTTP polling. That's because on the Lightning side of things, we haven't enabled WebSockets. They're not secured, so we haven't enabled them. If you're using a client that is not running inside the Salesforce platform, if you're using, for example, your own Node.js application, you can use WebSockets. But that's the limitation of the Lightning platform for now. We're not exposing WebSockets in Lightning components. So you have to disable them. If you do not disable them, the Bayeux protocol will try to use the WebSocket protocol. It will realize that it's not available, and it will fall back to HTTP. So that's a quick way to win in just a few seconds so that you don't have to check if platform events are available. This line is optional, however. Now that we have configured our Comet D client, next step is actually to do the handshake. So basically to check the authentication and to register, to connect to the Comet D server. So we use a handshake method, and we have a callback. When the handshake is successful, we can proceed. If not, we have to handle the error, of course. And once we are connected, we can then subscribe to different channels. So we subscribe to different platform events. Here we're subscribing to a platform event called myEvent__e, and we get a callback method that gets executed now each time we get a new message. So each time there is a new message, for example, we can log our message as a JSON string. That's a way to do it. So this is a really short way to receive a platform event. You can subscribe to, of course, more than one. You can have multiple Comet D subscribe statements with different platform events here. The only thing to remember is that you can have only one Comet D session active in a single page when you're using Lightning. That's a limitation of the Lightning platform. But other than that, you can write whatever code you want. You're free to process those events. You can fire events within also the Lightning platform. That being said, I'm going to show you a demo that uses platform events. So I'm going to switch to my code. I may have done something. All right. So I just realized that I did something stupid. I haven't prepared my demo completely, so I'll just have to ask you for a second. Can I do that? Yeah. Okay, so I am kind of stuck. Let me see. So I'm going to show you a demo called Northern Trail. And this demo is something you may have seen at one of the keynotes. It uses platform events to interact with a Heroku application. Now, this Heroku application I haven't set up. I forgot to set up, so I'm not going to be able to show it. So I'm sorry about that. I can show you the user interface. So what this does basically is that we have a shop that sells merchandise about or outdoor furniture like jackets, backpacks, tents. And the way Northern Trail works is that it makes bundles of their different merchandises. So, for example, the winter collection, we can grab several items and we can make a pack of those items. And then we can send them to the manufacturing division of Northern Trail, so that they can produce the items. Now, this is the part where this won't work. When you submit this mechanized mix to the manufacturing division, there's going to be a Heroku site that is called called Northern Trail Manufacturing that will receive the platform events. So you can imagine there's this window on the side with. That's a shame I don't have it. I don't think. Yeah. Okay. So basically, there's going to be a Heroku application or another website on the side. We are going to be sending the merchandise to the manufacturing division. The manufacturing division website is connected with a Comet D client. It receives in real time the merchandise mix, so basically the two items, the backpack and the jacket. And it's able also to fire back a platform event, which in real time updates this page. So I'm really sorry I have only set up half of my demo here. If you're interested in platform events, do check out the Robotics Ridge zone. We are using a lot of them, and you can see how we can update in real-time applications. So sorry about that. The demo is a bit short. So with that, I'll need to conclude. Today we saw how we can use an event-driven application, whether it is inside Salesforce or outside Salesforce. Remember the two aspects that are really important for event-driven architecture. First, it scales. And secondly, it brings decoupling. Breaking down a complex relation between different services is good, and you can do that with event-driven architecture. You can use, when you're using Salesforce, you can do that with platform events. Platform events can be used to control IoT devices, to control different applications that are, and you can do that in real time. If you want to learn more about platform events, there are 2 modules on Trailhead that are very useful. First, the platform event basics, which gives you theoretical information about what are the limits, how you can use it, how you can configure them. And then there's a little hands-on project that you can do in about an hour. It's very fun to do. You can build an instant notification application with platform events. So you're inside Salesforce, basically, and you have a console application that pops up, receives real-time messages on top of your Salesforce Lightning experience. So this is very fun to do. It only takes an hour, and you cover a broad spectrum of the features that are in Lightning and in platform events. With that, I'd like to thank you, and I will be answering questions. If you do have questions, please come up to the microphone. The session is recorded. And if you like the talk, please make sure also you rate it. Right. Thank you.
Are there any limitations or concerns or gotchas for ISVs for packaging the event object and using events in a managed package context?
No, they're packaged just like custom objects. So they can be sent to managed or unmanaged packages.
Cool, thank you.
Hi, I'm Srivatsan. So I think you were showing a demo where you were subscribing to it from a Lightning page.
Yes.
So if I move away from the page, should I explicitly turn off the subscription or will it automatically go away? Like an event happens in the back end.
So yeah, the subscription is using JavaScript, so as soon as you navigate away, it won't receive the messages. You can do unsubscribe from the Comet client if you want to do things really cleanly, and I suggest you do so because there are some limits about the active numbers of subscribers.
Okay, so an explicit unsubscriber is better from this practice perspective. Thank you. And I just have one more question.
Yep.
So you were showing an event-driven architecture where, like from a trigger or something, you can find multiple events.
Yep.
So this entire thing is asynchronous, right?
Yes.
So which means for the UI, we have to find a mechanism to, like if there is an error in the process, like propagate that back to UI. That happens behind the scenes.
Yeah, that's true.
Thank you.
Welcome.
So from a scalability perspective, on an integration point of view, what's the difference between using streaming API plus push topics compared to platform events?
It is in terms of limits, it is kind of the same.
Yeah.
Now the difference is that they're typed, and you can use also declarative tools. Typing is a good thing, generally, to enforce a certain structure, so I would suggest you use platform events. We are not working on expanding the streaming APIs. These were available before we got the platform events, so platform events are more or less the future of how we're going to operate with events.
2 questions. One thing I don't think you covered was logging.
Yep.
Is there going to be a standard Salesforce way of logging platform events after they've been sent?
So you can build, you can write a trigger that would actually create like records, but that's not something we do by default.
Okay. I was just curious if there were plans for that. That's actually what we're doing currently in production.
No, there's nothing like built in to do that, but defeats a bit the purpose of scalability, basically.
Right. No, totally get that. Second question, are there any plans to up the limits of the number of platform event like objects that you can create? I think there's a limit of like 200 or something right now.
So that depends on the type of license you have, yes. If you're using like developer edition, for example, there are like 5 different platform events that you can create, and after that it's up to the different types of subscriptions you have.
Okay, cool, thank you.
Yep.
What type of errors might you get when you're trying to publish?
So if the infrastructure is down, basically, you'll get a database, you'll get an error. And also if you hit the limits, because we're using DML limits, you can get an error. Just like when you create a new object in Salesforce, you can get some errors, same thing.
Okay, all right, cool, thanks.
From a testing standpoint, when someone subscribes to receive a published event, how are you validating whether or not they've actually subscribed successfully, and then whether or not the replay is needed?
Yeah. So for the subscription, the Comet D or library that you'll use to connect will tell you whether the handshake first was successful. So that's the first part. And then in the handshake, you can also get a notification whether the handshake was successful or not. Now, in the meantime, you can lose network connectivity. But that will be up to you to check this.
Okay. And then what's the cleanup mechanism for the messages for the platform events?
So each time you receive a message, there is the replay ID. It's up to you to store it, what was the last message you received, or fall back to the -2 for the last 24 hours and make a way to filter which ones you already received or not.
Thank you.
Nice doll.
So my question is more related to Marketing Cloud.
Okay.
Is this also integrated with Marketing Cloud? So can I send and receive messages?
Very good question. I actually do not have the answer. I'm sorry.
Okay.
So
And you have given 24-hour, for example, storage for this platform event. And do you need to, can you reduce, like for example, can you remove the message which is no longer required for replay, or it will remain for 24-hour regardless whether we
no,
acknowledge
you
it or
do not have access to the
So
replay
The message
stack.
will remain 24-hour regardless whether
Yes.
we use it or not. Thank you.
Yes.
Hi.
Hi.
My question's about API limits. The subscribers, I just want to make sure the subscribers don't hit the API limit, but if they're writing from an outside source, that is an API call?
So there are multiple limits that are in place. There are limits for publishing, whether it is using Apex or using like a process. And then there are also limits in terms of subscribers. We have a limit of active subscribers at a given point in time.
Okay, but if I have an external service, basically every time they're writing to a platform event in Salesforce, that's one of the API calls.
Yes, it is an API call.
Right.
Yeah,
Thank you.
you're welcome.
Hi. Is there anything in the project or product roadmap that would suggest we might expect parent-child relationships within this message
No,
structure?
that is really out of scope because we're targeting platforms that are like not source platforms, so we can only stick to what is actually writable in JSON.
Okay.
The way to do that, if you want to use complex relationship, is to keep pointers IDs targeting the objects.
Well, I'm using them, and I just basically am serializing some Apex classes and then sending them as a string. And
so you probably want to avoid that and just keep pointers to these objects.
okay. All right. Thanks.
Welcome.
Can you tell us about how execution contexts work with this? So if I have, events that keep triggering, is that all one execution context, or are they separate?
If it's in the same Apex call, it is the same context.
Okay.
So I encourage you to use the batch publish method. If you have multiple events that you want to fire, a single one will limit the DML statement limits.
Okay. So fire and async, basically.
Cool.
Yeah, on the client side, in the demo was the JavaScript library. If you had more enterprise level subscribers, are there Java classes that would support?
Yes, Java also has a Comet also have a Java implementation. So and actually, the reference implementation for the Comet is actually based in Java.
Okay,
So.
and is OAuth the only authentication protocol that's being supported right now?
Yes, that's part of the Bayeux protocol. So we have to have this header when we subscribe to the clients.
All right.
But there are also some OAuth clients in Java, so that shouldn't be a problem.
All righty, great, thank you.
On the replay, is that at the client, on the subscriber side, or on the publisher side?
It's on the client side.
Okay.
So basically, each platform event has a record type, has a schema identifier, and for a given schema identifier, we increase this number of the replay ID.
What I'm wondering about is, so we have an event that gets published, and we have 3 different subscribers. One of them was down for the last 2 hours. We want to replay the subscription for 2 hours for just that one client.
Okay, so it's up to the particular subscriber to figure out when he received the last message and replay them.
All right, thanks.
Yep. All right, any more questions? Well, thank you.